Nice. Question 3 just has one instruction. Simplify. However, I want to point out in this one that the defined part they wrote as part of the question. You might want to highlight these. Because sometimes students get confused going, what does that mean at the end? Well, they're just telling you where things are defined. They're telling you that in the first one, because you have square roots, the m value would have to be bigger than or equal to 0. The n value would have to be bigger than or equal to 0. In the second one, we have cube roots and square roots, but in the square root ones, you have a negative 3b. Do you see that b would also have to be negative to make it positive inside? So then the b values are less than or equal to 0. And finally, in the last one, you have square roots again. And so they have to be positive inside, which makes both the a and the b's have to be positive. So how do we simplify? Well, it needs to be written as a mixed radical in lowest terms. In a, that's already done. And then you can only add like terms. Can you see that this is alike with this? And this one is alike with this one. So those are the only ones you can combine. We can't put things that are not like terms together. So I have 7. In the purple box, I have 7 minus 3. That will give me 4 root m. And I have 2 plus 5. That will give me 7 root m's. Do you see that if you did the orange boxes first, and then the purple boxes second, you'd get the same answer but in a different order? That would be perfectly fine, right? Doesn't matter when you're adding and subtracting, it doesn't matter the order. Which is terribly fascinating. If you have little cousins or little siblings, a very fun mathematical thing to do to them. It's like not like a mean experiment, but it's neat to watch. Okay? Now you know if I said 2 plus 7, you get 9. And then right after that I asked you 7 plus 2, you're like, that's the same thing, that's still 9. But you don't know that when you're little. And so it's kind of fun to watch. And not in a mean way, but just neat to see that your thinking's not there yet. If you ask a little kid to do 2 plus 7, and they'll work, and it's kind of cute, right? Because they're thinking and they're working, and they go 2 plus 7, and hopefully they get 9, right? And then right after that, you ask them 7 plus 2, you would expect like, oh, you should say 9 right away. But they'll do thinking again. And it's like, oh, they haven't realized yet that those are the same thing. Adding doesn't matter the order. Okay, so B. In B, oh, I think they're trying to trick us here. If you read it too quickly, you might think they're all like terms. But can you see that they're not quite all like terms? Because some of them have cube roots and some of them have square roots. So this one has a cube root. It is only alike with this one. And this one has a square root. It is only alike with that one. So when I put things together, the 2 cube roots minus the 9 cube roots is going to be minus 7 cube roots of negative 3b. And the 8 and the 3 will give me plus 11 square roots of negative 3b. And I'm going to do a purple step here. Some of you might like to write the purple step down. Some of you might want to skip it. Okay, it's just in the purple step, I set things up and break things up. So 32, I need to see if I can pull out the biggest perfect square. It's going to be 16 times 2. It's also 4 times 8, but 16 is the biggest square root I could pull out. And then a to the 5, I would break that up into a to the 4 and 8. Minus 2. 45, I would break up to 9 times 5. And the b cubed, I would break up b squared and b. Plus 5b square root. The 25, I would do 25 and 5. And the b by itself. And finally, minus 2a square root 36 times 2 and a squared times a. So what I'm doing when I break it up is I'm looking for what are things that I can square root. I can square root 16. If you could see that right away, then the square root of 16 becomes a 4. When that 4 comes out in front, it hits this 3 and becomes 12. The square root of 16 is 4. The 4 out in front times it by that 3 will give us 12. The a to the 4 becomes a squared. I'll never need absolute values around the a squared. Why? It's guaranteed to be positive. Square root, I'm left with a 2 and an a. Next one. The 9 comes out in front, hit by that 2. That'll become 6, because the square root of 9 is 3. The b squared would come out in front. And we would have the absolute value of b. And then what's left is a 5 and a b. Plus. Square root of 25 is 5. That 5 hits this 5, give me 25. I have a b out in front, and so I'd be left with 5b. Square root of 36 is 6 times by the negative 2 is negative 12. A, the square root of a squared is the absolute value of a, and I'm left with 2a inside. Now, something that happens in this question that makes this, like, math gets really particularly quite quickly as you get into higher math, and paying attention to details is why so many courses want you to take pre-calculus. Because if you can pay attention to details, you'll probably be able to do that in whatever job that you're going to be doing. So what makes this one a little bit detail-oriented is the fact that they gave us this to begin with. They said part of the question, A and B are positive. If A is already positive and B is already positive, do you see that you wouldn't have needed the absolute values here either? Because if B is already positive, so what I'm going to do is I'm just going to take out a different color and I'm going to lightly scribble those out. We didn't need them. Same thing with A here. We didn't need the absolute values because that was given. If it's not given, like well, I guess it was the previous question, we sometimes needed the absolute values. But they told us already that A and B were positive, so that wasn't needed. Which is important because now, can you see that this, before with the absolute value, it wouldn't have been like terms. It would have been close, but not like terms. Now, those would be identical. Also, can you see that this, and without these, I would have a times a, which would make a squared. Now they are like terms. What's really nice about the orange boxes, see the numbers in front? 12 minus 12. I love writing that. So those cancel out completely, and we just have the minus 6 plus the 25. That will be positive 19b root 5b. After simplifying, this is all that's left. Circle question number 8.